Welcome friends to my YouTube channel. Now on yesterday's lecture we have discussed about the Coriolis and centrifugal forces. That is the pseudo forces that generates due to the rotation of due to the acceleration of frames. Okay. Now in today's lecture I shall going to discuss the effect of Coriolis force for a freely falling body, freely falling body on Earth's surface. Okay, the effect of Coriolis force for a freely falling body on Earth's surface. Okay, so this is the Earth rotating about a fixed axis ns poles. Okay, with angular velocity omega. Now this is the center. Say just we take a point P. Now we took x-axis towards the east direction, okay, and y-axis towards north direction. And this is the z-axis, and the angular velocity vector omega is parallel to the polar axis. Okay, so this is z, this is y. So this angle is also theta. So remember, x-axis is along east, y-axis is along north, z-axis is vertically upward. That means we have to throw an object from z-axis so that it can fall freely on Earth's surface, okay, along this way. And omega lies in yz plane. Omega lies in yz plane. That means it has no x component. Okay, simply, so omega lies in yz plane means j omega y plus k omega z, and this is along y, this is theta. That means omega y, this equals to omega cos theta, and this is omega sin theta. Okay, now the object is thrown vertically in the downward direction, say with a velocity v along z-axis. That means velocity only can have z component, z k cap. Okay, z dot k. Okay, that means velocity can be written in this way. Now what will be my omega cross v? Okay, this is Earth. What will be omega cross v? I j k, this is 0, omega cos theta, omega sin theta, 0 0, this is say z dot. So this is what I cap omega z dot cos theta, and other terms will be 0. Okay, so what will be the expression of Coriolis force? Simply minus 2m into omega cross v, I cap omega z dot cos theta. Okay, now remember one thing, that the body is thrown vertically in the downward direction so that it can reach the Earth's surface. That means body is falling in the downward direction. So here we can take the velocity negative since it falls in the downward direction. Minus 2m I cap omega, this we take say minus v. Okay, see if the velocity is v, so we take minus because there is a downward fall. This. So this is simply 2m omega v I cap cos theta. So this expression clearly indicates that this force only have a component along x direction since there is I cap. Okay, that means due to this force there will be an acceleration along this force, this direction. Okay, 2m omega v I cap cos theta. So there will be an acceleration along plus x direction due to this force. Okay, so what is this? Mass m multiplied by d2x dt2 into I cap. Since it is produced in x direction, this is the force and that must be equal to this force. Okay, so m I cap d2x dt2 2m omega I cap v cos theta. I cap also cancels. Okay, so if we integrate it, what we get? Two omega v cos theta okay into t plus say some constant. Okay, this is okay. Sorry, I made a mistake. That is, when the two forces are made equal, that is say m into d2x dt2 into I cap, this must be equal to 2m omega v I cap. So m I cap cancels, this is fine. Okay, so we have to replace v. We know v equal to u plus gt for a freely fall body, and initially the body is at rest, that means we take u0. So what will be my v? My v will be gt. We have to replace this value. Okay, that means 2 omega gt. Okay, now if we integrate this, what we get? That is dx dt. This is simply 2 omega g t square by 2 plus some constant, say c. Okay, so omega g t square plus c. Now we all know the boundary condition. At t equal to 0, the velocity of the particle is 0. Okay, so that means c, this is equals to 0. Okay, c, this is equals to 0. So here we must have to replace v by gt. Since initially the particle is at rest, we take u equal to 0. Okay, okay, now my dx dt will be omega g t square. Now again, if we integrate it, what we get? Omega g t square dt means t cube by 3 plus another constant c dash. Okay, now again, when t equal to 0, x equals to 0, that is we get c dash equals to 0. Okay, so x is what? X is 1/3 omega g into t cube. Remember this. Now suppose when the object is thrown vertically in the downward direction, suppose it covers a height h. Okay, suppose it covers a height h, so we can write h as ut plus half gt square for a freely falling body. So initially the body is at rest, that means u is 0, so we take h is half gt square. Okay, So what will be my T from this equation? My T will be 2h by g whole to the power half. Okay, so we have to substitute this value, 1/3 omega g t cube, that means 2h by g to the power 3 by 2. So we can take it 1/3 omega g, this we can write 2h by g into 2h by g to the power half. So g cancels, so this is simply 2/3 omega h. So there will be a cos theta term which I forgot. There will be a cos theta term. Okay, there will be a cos theta. 2/3 omega h cos theta into 2h by g to the power half. So this is the displacement. Okay, so this is the displacement of a freely falling body. Okay, so at first we have to find out the Coriolis force, and we have seen that this force only has a component along x direction. That means due to this force there is an acceleration produced along x direction. So after equating both the equations and applying the boundary conditions, we get this result. Now for a if when the body is thrown vertically in the downward direction, if it covers a height h, that means this side is h, we can write h as half gt square, since we take the body at rest initially. So from which we get t equal to 2h by g to the power half. So here we put this t equals to 2h by g to the power half, and after simplifying this we will get this result. Okay, so this is the very important formula. So this is the displacement of the particle when it is thrown vertically downward direction on the earth's surface under the action of Coriolis force. Okay, so this is the simple thing. So this force only can have an x component. Okay, now one thing I have to explain, that on my last lecture I have told that we can explain the direction of wind in northern and southern hemisphere. How? So what we see from the expression of Coriolis force, that is minus 2m into omega cross v. Okay, now if we look back, we are in the northern hemisphere. Say this is n pole and this is s pole. Okay, and the earth is rotating about ns poles with an angular velocity omega. Now you all know that from both the poles the cool air is moving towards the equator. Okay, from both poles cool air is moving towards the equator. Okay, cool air from both poles moves towards the equator. Okay, the cool air from both the poles move towards the equator. So that means in the northern hemisphere a cool air is flowing from north to south. Okay, that means velocity is along this direction. Okay, so if you take omega cross v, then the direction of this wind will be towards east, but due to the account of minus sign the direction is along west. So what we see, in actuality cooler air from north pole must have to reach south pole, but due to the Coriolis force the cooler air from north pole is deflected towards the west direction. Okay, so you can easily check it by drawing the picture in this way. Suppose you take the axis this way, this is n pole and this is s pole. Okay, so omega will be along this direction. So cooler air in northern hemisphere flowing from north to south, So what will be my omega cross V? Along this direction. Okay, but in account of minus sign, the air will deflect towards the west direction. Okay, so due to the account of Coriolis force, okay, the air that was flowing from the north pole will deflected towards the west in northern hemisphere. Okay, so that means if this is N pole, this is S pole, okay, the air must flow towards this direction, but due to the effect of Coriolis force, it will turn into this direction. Okay, that is west direction. So this gives rise to northwest trade wind. Okay, so in northern hemisphere, Coriolis force gives rise to northwest trade wind. Okay, similarly, what will happen in the southern hemisphere? Due to Coriolis force, in southern hemisphere, cooler air from south pole can move towards the north, but due to the effect of Coriolis force, it will turn into eastern direction. Okay, so similarly in southern hemisphere, Coriolis force gives rise to southeast trade wind. Okay, so this is the deflection of air due to the effect of Coriolis force in northern and southern hemisphere. So dear guys, if you don't subscribe my channel, then kindly like, share and subscribe it, and the link of this video will be given in the description box. Okay, so I will discuss few other things in my next lecture. Okay, thank you.